this is the calibration card cut out. And so the whole idea with this is that we have at the lower left corner in the lower left corner, you'll see that there's this crosshair. So we're going to move the tool, the machine, after we put this down. We're going to move the bit so that it's right over the crosshair, as fine as we can get it, as precisely over the center as we can, and then we're going to click a store button. And then we're going to move it, the tool, to 0.2. And actually we don't need to be on the crosshairs. It's easier if we get off of it here, just on the line. And then we're going to store that point, and then we're going to go near 0.3, and we're going to store a point directly over this line. And then we're done. And the reason for this is it corrects for any misalignments between the X and the Y axis. So, for example, if you have a square, a perfect square in Procam that you want to engrave on the board, well, if your X and Y axes are exactly square, meaning they're exactly 90 degrees between the X and the Y, then you'll get a perfect square. But of course, nothing that you manufacture physically is going to be perfect. So if your axes are a little bit off angularly, you know, there's some misalignment between your X and your Y, this makes it so that doesn't matter. Even if your axes are like this, you'll still get a perfect square when you go to engrave it, if you calibrate. And so that's a requirement. Before you start, you have to calibrate the machine. And the way you do that is just by measuring these 3 points. And the way you measure it is through the software. It'll tell you how to move the machine so that it's over each point, and it's over 0.1. You click a button, then you move it to 2, click a button, click to 3, or move to 3, click another button to store those coordinates, and then it will compute how it needs to adjust the commands such that for any XY misalignment physically, you're still going to get a perfect square when it calls for a square. So now we'll take the Calibrate card that we cut out, and we're going to tape it down. And we want this crosshair that's right over here, we want that to be over the board. We don't want it to be aligned exactly to this corner. We want it to be a little bit to the inside of the board, like right over here. That's where the machine is going to go, that number 1 crosshair. Every time it runs, that's going to be the home, basically, of your Gerber file. And then it'll move off and engrave everything. So that should be guaranteed to be on top of the copper. And to do that, however you're going to mount this copper clad, which you just saw in the earlier, you want this to be above it, as opposed to, for instance, having it like here, where that crosshair is aligned or it's off to the lower left of the board. That's not good, because now that means that the software thinks that there's copper here, and it, you know, if you had a design that went all the way to the edge, it might try to cut there, and there's nothing there to cut. And a worse scenario is if it tries to probe there, there's no copper for it to probe, and so it'll keep going because it won't see any electrical connection. When it touches, it'll keep going until it hits the plastic and then crash it to the table. So we're going to put it all, like maybe 1/16 of an inch, just a little bit to the inside. And to help stick this down, so the procedure is we're going to put this down, we're going to tape it so that it stays put, and then we'll just probe the area. And, you know, it's not super important if it's exactly straight, but if it is a little bit crooked, let's say you probe like this, and there's that angle there, it'll still work, but now every time you mill a board, it's gonna be rotated a bit, which is fine because then you flip it and it'll still realign, but you're gonna lose some work space area here. So just try to get it roughly by eye, get it square to the table. So I'm just gonna cut this out now. Just a couple of little notches here so that the tape can adhere to the paper as well as the copper clad. So there's one area where I cut out 2 notches so that the tape can both tape the paper and the copper clad. I'm going to do the same up here and over here. So this is what I have right now. Now we're going to tape it down. So the copper clad's already stuck down with double-sided tape, and it's not moving and it's not bouncing. It's good. We're going to take this, we're going to lay it down. Try not to really crease or crumple this when you do it. And I'm going to put this, actually I'm going to cut this corner because that might make it easier too. I'm going to leave the crosshair, of course, but I'm going to cut just the corner so we can make sure that the crosshair is on top of the copper clad. So you see I just took the corner off there, but you can still see the crosshair. So we're going to put that right on the board. And then we're going to make this horizontal line that's in the Calibrate card, we're going to make it roughly parallel to the table and to the copper clad board underneath it. Not going to be on top of the edge, but it'll be parallel to it. So once I do that, we're going to apply some tape. So I think masking tape is probably the best thing to use. I'm just going to cut a piece off. Just getting my tape now. Okay. So, make sure that's lined up. It's roughly parallel. And I'm going to put a piece of tape right down there. I'll put another one here so it doesn't rotate on me. And then I'll put some here too. Make sure the paper stays flat, it doesn't get wrinkled. So the way this works is that we're relying on the XY alignment of the printer that you use. So as long as you have a decent printer, it should be fine. If your printer prints out skewed, well then you're probably no better off. You might be worse if you use this method to calibrate it. But we assume that probably any commercial printer that you use is going to be very well aligned in X and Y and give you a nice square angle when you ask for a square angle. Alright, so now that that's stuck down, now we can move on to the next steps. Now, the next step involves using ProCam to actually move the machine and make the measurements. And this is also a good test to ensure that you installed ProCam successfully, because if you didn't, then you won't be able to move when you try to click the button to move the head. So, the next part of this video is going to be in ProCam. To move on to the next step, which is calibrating the machine, we're going to click the Calibrate button at the bottom. That'll launch this window, and you have 3 sections. So on the right, you have the section to move the tool, meaning the bit of the spindle, in the X and Y direction. So you have your X buttons laid out here, your Y here, and then for the Z axis, you have move tool in Z. So these will move you up and these will move you down. The reason there's 3 on each side is because these are short moves, these are a little bit longer moves, and these are the longest. This way you have a controlled way to move the machine. You don't want to crash into the edges or the table. Again, it's not the end of the world if you do. It shouldn't damage anything, but you want to avoid that, especially if there's a bit in there, then you will damage it, right? If you're crashing the bit into the table and it's a delicate bit, one of the small ones, then you have a high chance that you could just snap that bit because it's like a needle. So we're going to start. It looks like, I think, yeah, I already calibrated here, but that's okay. We'll just redo it. So the first step, obviously make sure the machine is turned on. You have Prometheus plugged in via USB to your PC. And then you can click, as long as it's safe to do so, meaning on the machine side of things, the head is off the table. So you're not going to drag it across anywhere. If it's not, you can click these buttons to do that. So mine's already up high, so I'm going to move it down. And then I'll show you on the video what that looks like. So if you just got the machine, you're going to see that this head is going to be over to the middle somewhere, and it's going to be basically on top of this table. And so to move it up before you start calibrating and move this head across, you're going to click the up button in Move Tool Z, and that will lift the head up. So you could click it a few times to get some clearance, and that's what it'll look like. So when I do this, I want to move up a little bit if I need to. And the reason for that is we need to have enough room underneath the spindle so that we can insert the bit. Obviously, if it's too low and it's barely touching the table, we don't have the clearance. We need to get our hands under there with the big clamp and the bit. So we're just going to move it up a bit. And now we want to choose from your starter pack one of the fine end mills. So for the purposes of calibrating, we're going to take the 0.005 inch 15 degree tapered end mill, and that's the one we're going to use because it has a very fine tip, so it'll be more precise when we use it to try to put the tip exactly over these lines or the crosshairs. So we're going to take this bit and we're going to do something a little different. We're just going to insert it without the bit clamp. So I'm going to put the bit clamp over here, and the reason for this is I want to be able to move it up and down, slide it up and down, to get it to drop down. It'll make more sense later on, but to let the bit fall a little bit and gently touch the surface so we can get a more precise measurement. So I'm going to insert this, and the way we're going to get the bit to stay is we're just going to engage the spindle motor, and that's going, once we put it in, that will keep it from falling out. So I'll raise this a bit so you can see. So the bit is inserted now, but I'll just do it in reverse. So I'll put my finger here, avoiding the tip of the bit, the point. So I'm putting the bit up, and now to make it stay, I'm going to engage the motor, and now that'll keep it from falling out. So now we're ready to continue, or really begin, the calibration process. So I'm going to click on, in ProCam, I'm going to click go to 0.1 set point, and then the machine is going to start moving, and this will take us to the approximate 0.1 spot, and then our job is to fine-tune it so that it's exactly over that spot, and then we're going to click store current location as 0.1 once we're there. So right now I'm just clicking the down button for the move tool Z section of the Calibrate window, and you can see that it moves in increments. And when it gets too close, I'm going to stop using the large step button and take some small steps. Now I'm going to move. I could tell already that it's too far to the left. So we could see that it's too far to the left, so now I'm going to click the go right button. Now is an overshot. So I'm going to go a little to the left. And I'm going to keep going down because the paper's crinkled up a little bit, but I'm pretty close. So I'm going to just take a small step. Okay, so now maybe a 1/16 of an inch above the surface of the copper clad. So I'm not going to use any more of the buttons because then I'm going to crash into the table. So this is where it comes in handy not having the bit clamp. So I can just disengage the motor, and now I'm able to grab the bit and try to get it down a little bit so I can see just by touching the depth ring. Okay, so it looks like it went down slightly. And I want to go maybe a little bit to the right. And I'm definitely too far up, so I'm going to move down in Y. That's pretty close. I'll go a little more. And now it looks pretty perfect. So I'm going to go ahead and I'm going to accept that as my 0.1. So I'm going to click this button, store current location as 0.1, because I'm right above the crosshair. So now that we stored 0.1, we want to move the bit to 0.2. But to do that first, since we disengaged the spindle motor, we want to put that back. So we have to engage the motor, and that will keep the bit from falling out, because now we have to retract the Z-axis. So I'm going to, now that I engage the spindle motor, I'm going to click this button here to move up. And that's really fine, because that gives me about a little over a 1/4 inch. So I can move across the table without any risk of colliding with anything. So now we're going to go to 0.2 set point. And by the way, you could also check that you clicked store current location as 0.1, because now the X and Y values will match the current position of the tool. So now we're going to click go to 0.2 set point. And that will take us approximately to where we need to be. And now for 0.2 and 0.3, we don't have to worry about the crosshairs. We just need to be anywhere along the line. It's good to give some distance, so it's good to be close to 0.2 and 0.3, but it's easier to align if we don't try to go on the crosshair, because then we only have to move in one dimension. So let me move the camera over. So now we're close to 0.2, and you can see we're to the left of the crosshair, and that's fine. We're going to stay there because it'll be easier to align. For the algorithm that the ProCam uses, it's not crucial that you're exactly on the crosshair. It doesn't matter. It's really looking at the angle. So we're going to stay on the line. And now I'm just going to click down a bit. And I'll click the smaller distance. Now another trick you can do when you get close, when you get worried about going too far, like into the table, you can take your hand and manually move. Let me get it in view. There is, you could see the Z-axis lead screw and the shaft coupler here. You can actually rotate that by hand. So that's what I'm going to do to get a little bit closer, and then I'm going to drop the bit down a little more by disengaging the motor. All right, so now we are exactly over the line that leads us from the crosshairs of 0.1 to the crosshairs of 0.2. We are on that line. So I'm going to store this. Store current location as 0.2. So click there. And now you can see we got those coordinates for 0.2 set point, the X and Y. So now I'm going to lift up the bit, engage the motor. So now the bit is in place, it's not going to fall. And I'm going to move the Z axis up, because now we have to rapid move over to 0.3. So I just moved up twice. Now I'm going to say go to 0.3 set point. So the machine is going to go home first. And then it moves approximately to 0.3. And again, we don't need to go on the crosshairs here. And in fact, it's easier if we don't. because we just need to get on that line. In this case, the line is vertical. It goes from the crosshair of point 1 to the crosshairs of point 3. So looking at it from my vantage point, we are too far to the left. But first I'm going to get a little bit closer. Let's go down 1. Now I can move it by hand as well. Okay, we're pretty close, so I'm going to leave it there. So now I'm going to get onto the line. So we're too far to the left, so I'm going to move to the right. A little bit more. That's pretty close. So I'm going to drop the bit to see exactly where we are. And now that we are directly over the vertical line that goes from point 1 to point 3, we're going to click Store Current Location as point 3. And that's it. So we have those 3 measurements that we needed. Now we can close this window, and Procam is going to save this information in its preferences internally. But if we, since it's tied to the local install of Procam, if you move Prometheus to another PC with another install of Procam, you're going to need to repeat this process.